Hello viewers, I'm Kausalya. Today we are going to see an introduction about RC series circuit. So here, as the name indicates, a resistor and a capacitor are connected in series and they are connected to a voltage source V here. So as we all know, R denotes resistance and here this is your capacitor C, right? And VR is the voltage across the resistor and VC is the voltage across the capacitor. And here XC is nothing but capacitive reactance, right? And I is the current that flows through the circuit and V is the source voltage. So first we are going to discuss the relationship between the voltage and current in a resistor and the relationship between voltage and current in a capacitor. So here you see, right? So this is how the voltage across the resistor and the current in the resistor will be. That is, they are in phase, right? Whereas here you see, this is the relationship between voltage across the capacitor and the current flowing through the capacitor. So here in this case, the current leads the voltage by how many degrees? By 90 degrees, or we can say voltage lags the current by 90 degrees. Okay, in both the ways it is correct. So now we are going to combine these two diagrams. So when you combine these two diagrams, you see here the current remains as such, right? So when you combine the voltages, so here comes your VC, right? This is your VC and here this is your VR. So here VC is drawn and here VR is drawn, and when you add these two, that will give the total voltage V, right? So this is what, in order to show how to calculate V, this diagram is drawn, right? So VR is nothing but, as we all know, it is I into R, and VC is nothing but, voltage across the capacitor is nothing but, it is I into XC, right? XC is nothing but capacitive reactance. So here from the triangle you see V square is nothing but, it is the summation of VR square and VC square, right? So VR, that is VC, since it is found to be lagging, here a minus is included, right? So VR whole square is, VR is nothing but IR and VC is nothing but I into XC. So anyway, taking square will make the negative terms as positive. So here in these expressions, we are taking I square commonly outside. So when you take I square outside, the remaining terms are R square plus XC square, right? So now, you see I am moving this I square to the left hand side. So V square by I square is equal to R square plus XC square. So squaring on, that is not squaring, I am taking square root on both sides. Right, when square root is taken, this becomes V by I and here this becomes square root of R square plus XC square. So V by I is nothing but our impedance. So Z is nothing but square root of R square plus XC square. So when we draw impedance triangle, you see this is your resistor R and this is your capacitive reactance, and when you add these two things, here we are getting our impedance Z, right? Again, here this is your pi, that is phase angle. This phase angle is given by, that is tan pi. So tan pi is nothing but opposite by adjacent side. So here the opposite side is XC and the adjacent side is R. So pi is nothing but tan inverse of XC by R, right? And power factor is nothing but, it is cos of pi, right? And cos pi is nothing but, again when you take here from this triangle, when you calculate cos pi, what is the formula for cos pi? It is adjacent by hypotenuse. So here the adjacent is R and the hypotenuse is Z. So therefore it is given by R by Z, and that too this is a leading thing. And here the real power is given by VI cos pi, reactive power is given by VI sin pi, and apparent power is given by V into I here, right? So when we use phasor notation, that is, you see here V is taken as reference. So V is given by its magnitude and the phase angle is 0 degrees, since we are taking the voltage as reference here. and impedance is given by R minus jXC, right? And when you write impedance in phasor form, this is your magnitude. Since we are having a minus sign here, the angle is with minus sign, right? And by Ohm's law, I is given by V by Z. So just substitute the values here. So when you substitute here, that is V with an angle of 0 degree and Z with an angle of minus pi, right? So the thing is, again, V by Z is nothing but it is your I, right? So I magnitude with the, when you move this minus pi to the numerator, that becomes plus pi here. So you see, V is given as V with an angle of 0 degrees and I is given by I with an angle of pi degrees, right? So here comes the end of this derivation. If you have any doubt, let me know in the comment section. Thank you.